If you find these videos helpful, please consider supporting AddOhms and the Bald Engineer on Patreon. Hello, my name is James. Welcome to an AddOhms live stream. Or Bald Engineer live stream. One day I got to decide what I want to call this. So tonight's stream is going to be, basically we're going to play around with an Apple II GS. There was, let's see, it was last week or the week before we were working on the schematic for the 2GS, and somebody mentioned to me that there are, is there no volume? Yeah, so if you can hear me, say hi. Yeah, so if you can hear me, say hi. Yeah, I can hear I've got volume. So anyway, we were working on the Apple II GS schematic, and so we're working on the Apple II GS schematic, and somebody mentioned to me that there are design tools for the Apple II. And so we are going to take a look at some of those design tools, because I was actually surprised. There's quite a few. Now, I will, spoiler alert, I already looked at some of them, and so some of the disk images I have won't load, but that's just going to be what it is. So, totally forgot. I wanted to say hi everybody in chat. I see lots of people saying hi. Oh yeah, that's because I told you to. Cool. So the setup I've got going on, and I realize now I don't really have a good camera angle for it, but you can actually kind of see over here, I've got an Apple II GS with the RGB monitor, but I'm going to be connecting the, I'm going to be connecting it through a composite interface so that you can see what the screen looks like. And so, for example, let's see if it's working, because it actually looks like it's having trouble at the moment. And let me do this. Let's see, all we have is a blank screen, so that's not good. So let's figure out what's going on with that. Go to video capture. It is this. Okay. Huh. Maybe the cord came unplugged? Well, this is kind of a critical component. We need to make sure that that's working. Okay, there we go. Okay, so let's, just to give you an idea while we talk through some things, there's a demo disk on here that I can run, and then that way we can make sure that the Apple II is still working. All right, so what I've got is, I've got this emulation device. So it emulates a floppy drive, and it takes an SD card, emulates a floppy drive, and so we'll be using that to load some disk images. I had originally hoped that we were going to be able to use a serial transfer cable and load images onto the 2GS and then write the disks, but if you watch last night's stream, the cable that I got doesn't work very well, so I decided not to do that. And then my next thought was, I've got a device that can write the magnetic flux lines of a disk image onto a disk. It wasn't until last night that I learned it doesn't work with Apple II disks. So we're going to use the SD card reader. It's not as fun to me because I really wanted to have the disk drive running, but we will get all of the experience of using an Apple II, but without any of the slow disk or even with the slow disk access. Okay, so the first thing, okay, so let's kind of move on. The one thing I wanted to say is I'm using an Apple IIgs. All of the software we look at tonight is Apple II software, which I think is funny because while the IIgs is by far, I think, the best computer from the 80s era, nothing made use of its advanced capabilities. Everyone that bought it to run IIgs software, or I'm sorry, bought it to run original Apple II software, which is exactly what we're going to do with it tonight. The only reason we're using a IIgs is because my Apple IIe doesn't boot, and I don't know why. So we may do a stream on where we try to fix that one. So let's move back over to our computer. And here we go. Let's do this for the first couple. Let me show you what I am doing. So here's what my emulation device looks like. Let's see if I can get it so you can see the screen without glare. So I'm going to eject the current disk, and we're going to go down to, let me think, which directory am I in? Okay. So we're on this demo. This is the full program, but I don't think it's cracked, so it doesn't work. So I'm going to try whatever this digital circuit simulator is next. Okay, so it's loaded that disk, and now we just need to do a reboot on the IIgs, and we'll be good to go. Let's see what this is. Soft docks are on the oh, darn it, I didn't want to do this one yet. I've played with this one a little bit. I think we're going to come back to this one just because I've already kind of played around with it and I wanted to try some others out. So, whoa. Hey, HL521, thanks for the follow. Okay, so yeah, we're going to come back to this one because I have played with it a little bit, and I know this one works. I haven't quite figured out how to use it, but I thought that would be a really fun thing to do. This is actually, by the way, the program that somebody had recommended to me, and so I wanted to make sure that we take a look at it. But like I said, let's come back to this one because this one, I know this one works, and I wanted to try out some of these others. So I have no idea what this one is. It just says electrical engineering on it. So let's boot that and see what happens. Have you got any experience with KiCad? Well, if you check out the videos on my Twitch channel, most of my streams have been designing schematics with KiCad. And then last week we designed a circuit board, a MOSFET circuit board, which we did this in KiCad, and then last night we soldered it up, and it looks like it's going to work out pretty well. So yeah, I'd say I've got a little bit of experience with KiCad. Okay. Oh, this one. Okay, this one has, let's see, run circuit designer, run circuit simulator, runs. Well, what's the difference between 2 and 3? I don't know what input and sim module are. So let's just try run circuit simulator and see what happens. So if you are having trouble doing either schematic or PCB layout, if you go to my YouTube channel, so youtube.com/AddOhms, AddOhms, there's a link on Twitch for it. I have a series of videos where I designed a custom Arduino PCB. In fact, it was this one. I call it Pyramid Arduino. It turned out to be a triangle-based Arduino Nano. And so I take you through how do you lay out the schematic, how do you do the PCB design, and then testing the board. It's not meant to be a step-by-step, here's how to use KiCad tutorial. It was really meant to be more of a, here's how you design, or here's the steps you would go through to design something. So I would say at least give that a shot, because at least maybe I'll give you an overview, an idea of where to go. And then if you watch some of the live streams, one of the things I do try to do when I'm using KiCad is talk through the hotkeys that I'm pressing so that you know what to do. Okay, so we've got, oh, this is going to be like a PSpice simulation. All right, so CRT only. Let's see if we can retrieve from disks. It'll be disk 1, and then catalog is the ProDOS command to basically list their directory. Review catalog, yes. Did I hit? All right, insert data disk in drive 1. Well, I don't have a data disk, so I'm hoping it's got something we can load. I don't know what any of these things are. Okay, and I totally didn't see. How did we ever get anything from the 80s designed on a computer? Because I know it's going to happen. I saw something called hello. Let's see if we load that, if anything happens. Okay, file not found. All right, let's try this again. Retrieve circuit from the disk, disk 1, review catalog. Oh, I wonder if the other file I have, if that is, I wonder if that's like data files. Okay, because these all look like I'm going to try loading this MOS. I'm sure that means MOSFET, but it's probably like a model, and it's probably not a simulation file or whatever. Okay, so it says current circuit is MOS. Simulation time is 1 microsecond, going in increments of 1 nanosecond. So I'm just reading the top 4 lines. Let's go ahead. I don't know. Let's set all volt. No, let's. I don't know. Let's just hit 6. Run simulation. See what happens. Estimated simulation time. 14 minutes, plus or minus 20%. What? No, don't do that. Seriously, our simulation time is 1 microsecond, and it's going to take 15 minutes. Okay, let's at least review the circuit variables. So I was thinking, my first thought is this would be a net list, but it only has branch numbers, so I don't know what that means. Okay. So if we change this to 1e -9, and we change our time increments to, let's say, 500e -12, right? So that's, I don't know if that's going to work. So I want a nanosecond, and, oh, I know what I want is, I'm trying to get like 10 increments to see if that, so if it's 1 nanosecond, that's 1,000 picoseconds. So I want 100 picoseconds as my increment. Let's see what that does. Okay, run simulation. That will take 13 seconds. Okay, let's see what that does. It crashes it. It crashes. Okay, alrighty then. I want to try this. There's a second disk image with the same file name, so let me just load that disk and then reboot and see what happens. Because it's got DOS on it, so let's see if it's got something else, or maybe it has data files that we could use. And then I'm also, see if we can get some music going. Because now I'm thinking about it, the Apple II doesn't really have a lot of applications with music. All right. Speaking of music, I was looking for, and if anyone knows of any, I looked around for some Commodore 64 design tools, and I couldn't find anything on the C64. So we lost the video again. Let's try that. And so if you guys know of anything, please let me know. music. Let's change this to music. Nope, not game. Go to music. Play. All right, so I turned some music on. Let me know in the chat if it's too loud. If it's too quiet, let me know that too, but trying to keep it about there. Okay, so this is a different simulator. And this one, okay, so let's run Logic Designer. I don't know, let's see what that is. It's number 1, so it must be better, right? Initialize data disk. Yeah, we don't want to do that. That would be bad. Okay, it's loading something. The virtual disk is flashing, flashing, flashing. Well, see, these keep wanting to, I don't know what page means. Oh, I guess page of the thing. Okay. So now we're on a screen that I've seen this before. Now I recognize this program. Is this where you'd hear the disk clacking? Actually, you would hear the disk clack whenever I reboot, which now I think about it, what I should have done, I should have left my disk drive out so we could make the noise at least once. The problem is I can't hook up the disk simulation box and I can't hook up the disk simulation box and the virtual disk and the real disk drive at the same time. On a regular Apple II, that works fine. But on the 2GS, it just doesn't support that option, which is a bummer because I'd really like to be able to do that. Why is that black? Oh, because there's nothing there. Okay, so this one's not working. Let's move on. Let's eject this. High-res electronic designer. This might be interesting. Yeah, actually, that time it wasn't the. Oh, I hit escape. That time it wasn't the display losing sync. It was just that's all that program seems to do. So I don't know who cracked it, but it may not have been cracked correctly. Uh-oh, I'm displaying somebody's personal information. Somehow don't think that phone number will still work. Hey, Flame Die, thanks for the follow. Okay, I see a cursor. Does that mean we're supposed to press something? Looks like it. Okay, high-res electronic design. So I think what this is referring to is one of the graphics modes for the Apple II. There's like a high-resolution graphics mode. I don't really know the graphics modes that well, so I can't tell you what the different ones are. I just know that high-res is something that at the time was very special. It allowed for a lot of really good graphics, but it was incredibly difficult to program for. There's a game, Nox Arcanist, I think. It's coming out very, very soon that uses high-res mode, and it looks gorgeous for an old 8-bit system that uses NTSC tricks to make color happen. Okay, so let's see. Let's see the disk catalog. I would like to start with if there's something that we can. So sample. What I would like to try, let's try to load sample. So where's load at? Get stored picture. Is that what that means? Okay, the disk drive is active. There we go. schematic of a device that does nothing but looks cute. Well, can we even tell what any of this stuff is? If I move my mouse, can you see that? Yeah, so this looks like a PNP transistor because I think that's an arrow pointing in. And then this might be an NPN. Excuse me. There's a switch. This is probably, wow. Okay, so on the RGB monitor, I can tell that this is an inductor. And it looks like it's supposed to be a variable inductor. And then this looks like a transistor, another inductor. And this is just kind of a weird setup. Well, I don't know if this is a transistor, because why would it have a line that it connects to something here and then the base is here? So why, or is this supposed to be a box? Okay, all right, fair enough. They claim it does nothing. Let's move on. So let's do another disk catalog. And actually, did you notice how it's swapping? So this is like the text mode, and then it goes into the high-res graphics mode to display the what do you call it? All right, let's see if there's anything else on this disk. So sample had a B next to it. So I wonder, let's try loading audio and see if that does something. Whoa. Wait, I don't know what I just did. I want it to do get stored picture. So 7 and then audio. Okay, disk is loading that. Let's see what that does. And then we're gonna try to draw one. We'll see what that looks like. I just love this. Look at that. Could you imagine? You know, who was talking about KiCad earlier? HL521. Could you imagine if this was the output of your schematic? I mean, hey, if we went back 30 years ago, 40 years ago, this would have been super cool to have and see, but gosh, is this kind of a mess. So, looks like we got a battery going into a resistor for some reason. Maybe, nah, I don't even know. This is a capacitor, and then this is another resistor, ground. Again, I can't really tell what this transistor symbol is on either of the displays. Let's see. So I guess this is the audio input. So maybe this is supposed to be like in a, is this supposed to be like an emitter follower? This must be a transformer maybe, going to a speaker. And if, okay, so that cap is that's probably a coupling cap. So Spirit Realm thinks this is a PNP. I'm gonna agree with that, but it's just so hard to tell. Well, I guess if we think about, well, see if it's an emitter follower though. Anyway, so capacitor coming over to this one. See, now this one, to me, it seems more clearly like it's a PNP. And then, wait, so then what are these two terminals? Are these supposed to be an input as well? Okay, well, that was kind of interesting. Let's look at one more and then we'll try to draw our own. Let's look at what telegraph is. Get stored picture, telegraph. Let's see what that looks like. Hey, RJ Helms, good to see you again. This one is, it's just called high-res, I think it's just called high-res simulation, high-res electronic design. And this one is from the AddOhms archive. And if you don't know where that's at, let me know and I'll show you later where I got most of what we are looking at tonight is from an archive called the AddOhms archive. And then some of these are from archive.org, which we'll get to next. But this one was from AddOhms. Yeah, so this must be like a CW generator, and then a keyer. This is probably, yeah, a transformer with a tap. Rectifier, cool. That is pretty cool. So one thing I just absolutely love about Apple II graphics is the whole rainbow effect that occurs. And if you go look up, there's a couple of resources that talk about why this color bleeding happens. Probably the easiest one to who did it was a 8-bit guy. Did a pretty good job of explaining what's going on there. But it was basically Wozniak was trying to figure out how to get color without complexity, and he came up with a way that it works. But oh wait, can we? Okay, I have no idea what's going on. So I did draw a schematic, and now we can do things, but I don't know what's happening. So I'm pressing arrow keys, but I don't know what that's doing. If I try to up, down, left, right. Okay. Okay. Command options, component number. Okay, component number 1. But I wonder if there's like a problem because it's running on the 2GS, or what if I put in 0? Oh, there we go. Line from last point, dotted line, begin line, choose line color, space, knob 0, knob 1. Oh man. I wonder if this is expecting me to have like some kind of external device, because I've already run into one of the programs, and I'll boot and show it just because it's kind of cool. But some of these I think are expecting external hardware, and since this says knob 0 and 1, and I can't seem to move the parts, I'm guessing that we have to have something, yeah, like a paddle. Okay. Wow. Well, that's a bummer, because I'd really like to, okay. Okay, that's kind of a letdown, but that's okay. Let's do, yeah, next stream, making Apple II paddles. So this is the first, this is the first program we've looked at where I would really like to understand the hardware that it requires, because it looks like it could be functional. So, okay, we're gonna move on to the next one, and it's called Logic Designer Disk 1, 2, 3, 4. No idea. So we'll start with disk 1 and reboot. Make sure that the screen comes back. It does. Steve Wozniak, the Wizard of Oz. Yeah. That was or still is, oh, not this guy again. Why do I have this so many times? Let's try it again, but this is the same. We tried this one a few minutes ago, and when we got to I think the problem is it wants a blank disk. So I hit 2 to run the program. It's loading something from the drive. We'll be using drive 1. So if I say drive 1, we start at page 0, and now we're to this, and I have no idea what to do. I'm trying to hit everything. So, oh, I wonder about maybe Apple. Hold the Apple command. Nope. About control. Nope. All right. No idea what that does. Smash all the keys. Actually, funny enough, this is my second keyboard. I have another 2GS keyboard that stopped working last night when I booted everything up to make sure it was working, which I'm glad I did because it seemed to have been broken. Oh, cool. You found an article on the color system? Lost the display. Spectrum again? Arg. I just don't have any faith that this is going to do something. Let's try analyzer. Put data disk and drive 2. Well, I don't have a drive 2, so next. Well, we're going to try. I want to try and see what the designer does. I wonder who this Spectrum software was, because they had a lot of different programs for design. I just can't figure out how to make any of them do anything. Yeah, okay. So we can't really do anything on this one because we don't have a drive 2. Or can we? All right. Maybe I said that too quickly. I wonder if it's just not going to let me save anything because we don't have another drive. Okay, so this one has same cursor commands. IMJK. Nope. IJK. And then INM. Aren't these? Isn't that Vim? Oh, Spectrum did microcap, huh? Wow. Okay, that's the one that they just released recently, right? Or they basically released into freeware. All right. Okay, we can do a begin line. I did. Okay, so we can draw lines. E to end the line. I said E to end. Okay, well, that's kind of dumb. Let's do add, remove, end. Wait, what? Must be, oh, I missed that. Line end must be on a grid point. Well, what the heck is a grid point? Can we just do this and then say end? Okay. I don't quite understand what we just did. Let's try add, type a component. Oh, come on. We have to guess. Resistor. 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 Direction. Up. Parameter. God. Oh, you guys can't see it. Shoot. There's like, so down here is a menu. Up. Yeah, let me try this, because, there we go. Yeah, so parameter 100. Okay, so we got a resistor now. Cool. So what I had done before is I did add, and then I typed in resistor, and it didn't take it. And then R, didn't take that, but it took RES. So I'm gonna try cap now. And then direction, let's go right. Parameter. I don't know, 10UF? Okay. And then begin line. And I'm gonna move this to over here. Inline. Oh, look at this. It's like I know what I'm doing. Begin line, move this over here. And then we're gonna come down here. Oh, went too far. Can we remove? Okay, no. So I'm gonna do that, and then I'm gonna try to inline. Let me do that. But I don't know if I can delete this thing over here now. Oh, this is... Cool, Malcolm. Thanks for figuring out a clever way to get the URL into chat. I think that should be enough information for us to all find that. In fact, I want to make sure I look that up later. So let me just make a quick note. Hopefully microcap has a better interface than this. Yeah, I mean, I would love to know how much money they charged for this back in the day. So let's see what other components we can add. So I did IND, so that's probably going to be an inductor, parameter value. I'm just going to say 1. Okay, if you call that an inductor. So now I wonder how we can get a transistor though. I wonder what they would call it. So type of component Q, BJT, PNP, or what did I just do? NPN. Okay. This is like a Sierra adventure game for nerds, because we're trying to figure out what are the commands to make it actually do something. You know, it's like how do we get it to make anything? Parameter? Well, what in the world would the parameter be for an NPN? 100 money units. It took it. Whatever. And what is, God, I guess they're trying to say that up here is this must be the emitter, that's the collector, and then that's the base. And I guess maybe what they did is added a line so you can be on the grid. Okay. Let's try a MOSFET. FET, MOS, in channel, NMOS. I tried MOS, yeah. Wait. When did, yeah, CMOS was popular now. The name of this one is Microcomputer Circuit Simulator. That's all I've got on the name. I could do a reboot, and then that way we maybe. Okay, now that I know okay, let's do this. Let's add a resistor left. That's fine. Okay, let's quit. I don't want to save the data. Let's do a none of the above. So this is, here's the name of the program. Is it showing up? Yeah, so it's from Spectrum Software, and it's Microcomputer Circuit Analysis Program. Which makes me even wonder more than what is it asking for on the value of the transistor. I wonder if it just wants the HFE. So did we try to retrieve from disk? Let's see if this one has a sample. I guess, I think this one must be trying to use drive 2. Yeah, okay. Okay, so that's going to be we can't really do anything because you use the designer program to create it, and then the analyzer program must be to analyze it. And I don't have a second disk drive, so we can't. Yeah, okay. And then this is where so that must be what this is really doing, is it's basically like a PSpice simulator. So you can draw a schematic, which will then create the netlist, and then you come into the analysis side, and you can do analysis. Because, I mean, it's got AC, transient, yeah. I just wish we could actually get it to do one, but without a second drive, that's going to be a tough one. Oh, so you're thinking this is the very first version of microcap? That's awesome. Oh, I get it. Microcap. Micro Circuit Analysis Program. Okay. Let's at least do 6, because it says review, edit, standard components. Would this at least tell us? Yeah, Yeah, it needs the other disk drive. Damn it. That's a shame because, well, I only have one 5 1/4. I really got to get this ADT cable, because if I could get the ADT cable so we could transfer the files over, basically transfer the files over, we could write them to disk, and then we could, or what I need to do is get my Apple IIe running, because I have two of my emulators, and then we could do that. Okay, I think we're gonna bail on this one because all we can really do is play around with that schematic, which we might come back to and try to make a real schematic, but Apple II circuit design. Electrical engineering, high-res, logic we did, microcap. Okay, and the last one on this, okay, we're not gonna do that one tonight, or we're not gonna do that one next. I wanna do these others first. So, okay, I'm just gonna show you this one really quick because I wish it worked, but this one is, I was playing with it right before the stream, and it's either looking for a mouse or some other kind of input device, but it looks kind of cool, and I really wish I could get it to work. So I thought maybe if I show it to you guys, if maybe somebody could find something out about it, then we could do something with it later on. But it's just called Circuit Plotter, and it's from Sujanto. And already, like, you just kind of look at it, it's like already the schematics sort of look better than the microcap stuff. Although I'm starting to understand now what microcap, or not the microcap, what was the one before that? The high res. And this is as far as I can get because the keys don't do anything, and I'm thinking that this flashing cursor is meant to be like a mouse or plotter or something. And when I looked at the archive.org version of this, which archive.org does, I think it uses MAME as its simulator, but it actually starts with this cursor up here for some reason and hitting like the shift key or control, or it was, what did I just do? Okay. I don't, okay. Is it me, or does these things totally look like asteroids? The ship from asteroids. Okay, wait. Am I doing anything? I totally feel like a little kid, like back when I played with my brother's VIC-20. I would like turn it on and just start mashing keys and be like, is it doing something? Okay. David suggests that I just tap randomly, which is what I'm trying. What if we take it out of caps lock? Does it? No. See, I think it's looking for like a mouse or something. And the 2GS mouse does not, I don't think any Apple II programs recognize it. So, okay, so that was Circuit Plotter. Like I said, I think this one looks really interesting. I just can't figure out what it needs. So I want to try to look into finding out if it uses, is it like the other program that it needs a paddle, or is there like a type of mouse that it might have shipped with? Because I think this one looks like it could make some cool schematics. All right, let's go to the circuit simulator. So we're gonna go on to the next one now. Oh, what? Wait, how did I get back up? Oh yeah, no, this one doesn't do anything. This one actually is what broke the video before, so let's not play with that one. Okay. So we've got two more that I want to go through. This one and then the last one are the two that I think are going to be the most productive in terms of trying to see us do something. So I'm glad that they're the last two that we're looking at, because I mean, the microcap stuff, so that's three programs that I think we ran into. No, microcap, we just need I need another disk drive so that we can have the program and data disk. And I think I've got the other disks. I just don't have a virtual drive to put them in. And then 2 programs require some type of pointing device, and I'm going to guess that they're different. So I don't know if you caught when this one was booting, but I noticed it before, is it has a date of like 1992. So it's a relatively new program, and I think the kind of graphics on it really show. So here's what I built right before the stream because I wanted to make sure that it was going to work. So you can take and you can put in a battery and a light bulb and a switch, not a Nintendo Switch. And then you can wire them up with either copper or nichrome. I'm not sure why there's a difference or why it's offering 2 types of wire. I mean, I understand that they're different types, but... And then you just kind of connect this together. So we're going to place another wire, another copper. And it's got a pretty nice grid system, which is impressive. Ah, too far. Up and there. Okay, so we can create like this circuit, and then we can hit the switch and it makes the light bulb turn on and off. So that's kind of cool, right? But that's about all we seem to be able to do. And I don't understand because it's got all of these other blocks where you can put circuits, but it looks like these are the only 4 components that it has. Let's see what this arrow goes to. Yeah, see, it's going to help. Objects. So battery, bulb, motor, or switch. Yeah, so it's only got the 4. Okay. Battery, 1.5 volt battery. 18 levels of brightness on the light bulb. Okay. Well, then how do we change that? Oh, wow, check that out. So we only had like 30 to 50 milliamps going through it. It lights all the way up. So how do we get that to happen? The motor rotates. Okay. Okay. Well, let's do this. Let's go and add more batteries and see if it makes the light bulb brighter. So now we need to, it's accessing the disk. Okay, wire. Let's remove this wire. Done. And then we'll add another battery. And we'll just put a bunch of batteries in here because more is always better. Let's go to wire, place a wire, copper. All right, place a copper wire. So this is the least technical of all of the tools we've looked at, but it's the most functional. And it's kind of cool. The next one, actually, the next one is a little more technical. So, okay. So we'll do another test, and now I will. Okay, so I don't know if you noticed, but before we had like little dots on the filament, and now they're lines. So we must be driving more current through it. I don't know. What happens if you cause a short? You know, I love you, Empire. You always ask the critical questions. Tell you what, let's do this first. I want it because I didn't realize this was a motor. Let's put a motor here. Oh, it won't let us do that. How do I don't know how to delete this. Okay. I want to play with the motor first before we go blow stuff up. So let's just put the wire. We'll just wire the motor in here. I don't even know where my cursor's at. Oh. So, nope. Wire. Place, copper. we're gonna go here, and then we're gonna go, nope, here, and then we're gonna go here. So basically I'm gonna put the motor in series with the switch and the light bulb. And now we can go and test that. Oh, that's cool. Okay, when we press enter, it tells us what the current is. Yeah, I know that's 1.5 volts. So let's see, if we go to the next page, I remember the next page had a clear. Did it have a delete? Well, if it clears it, that's okay. That's fine. Okay, so now what we can do is let's add a battery. And now we'll add a switch. And then we're gonna short this out and see what happens. Done. All right. Now what happens when we go to test? Aw, what? Aw, won't let me do it. Really? It figured out that it's shorted? That's dumb. Aw. Well, there you go, Empire. It won't let us do it. So this is the first step in designing the cutting edge Ryzen CPU. Well, you know, everyone's got to start somewhere. Okay. The only other thing I want to do on this is I want to make that motor spin, and then we'll move on to the last one. So how do let's go and delete this. Okay. Now let's add the motor. Keep your motor running. Battery. I should have paid attention to what they said the voltage for the motor was. So let's do, so that's 1.5, 3, 6. I'm just gonna take a wild guess that it needs 12 volts. And then we're going to wire let's go, we're gonna make it so that, hey, thanks for the follow, Pugman. Do this one, then we're gonna place copper. So I wanna go plus, minus, plus, minus. Oh, nope, that's dumb. Place copper, plus, minus. Hey, Captain Solo, thanks for the follow. Ah, it wraps around. Wasn't expecting that. Sorry, no object is found. Well, that's sad. Come on. Let's come over here, place this one, copper. Okay, so I want this to go to, I think I'm doing this right. It's because that second battery was already connected. I'm not wiring these in the order that I normally, or that I think I would have done it. So yeah, I messed it up. Oh, no. So now this should go to this side of the motor, and then that. That is not a short, just a low resistance, high current circuit. Yeah. Is the thing that looks like a Napster head a battery? Yeah, I think it is. That's Check that out. See, it's spinning. How about that? What a fun day. I don't know. What do you guys think? Is it better to do it this way or with an Arduino? Which one is more fun? Oh, that's good times. Okay, so we got this simple thing working. All we got to play with are the motors and light bulbs, so I'm gonna move on unless there's something else that people want to see, or if there is, we'll come back to it. Don't put your finger in it. Yep. Let's try something. Let's go circuit name. Uh-oh, I did it lowercase. I wonder if it's going to be... Yeah, okay. It doesn't like something. That's okay. Well, let's try it again. Let's try it with capitals. I don't know if it's missing this directory, I guess. That's okay. All right. Let's move on to the next one. So let me load. Oh, wait. One more. Okay, we're gonna go do something else. I forgot about, there's this disk, and I think it's all basic programs. So let's take a look at that one, and then we're gonna get to the one that I really wanted to get to tonight. So there's a bunch of stuff in here. I guess, how do you load BASIC? Is BASIC in ROM, or do you have to have a disk with BASIC? I don't think it's in ROM. I think it's, oh man. So I don't think we can load any of these. It is on the Apple II, right? So how do you load BASIC? We are, okay, let me think about that. We're in Apple II mode. So how do you load app? Is this BASIC? No, I think this is DOS. Okay then. All right. Okay. Let's try load. Good call, RJ. I thought this was just like the DOS prompt. Captain Solo, you found the AV slider? Yeah. Yeah, well, I guess there's still, I don't know. So the TV I have is 3 years old, and it's a 4K. And I know it has the digital TV tuner, but I don't know if it'll even take an analog TV signal. Well, I regret doing lists now. Why did I do that? Yeah, I've been using my 3D printer to print the headbands, the bands that go around the head. Do I have one? No, it's over by the printer. But they go around the back of your head to hold the straps for the face mask. I actually wore one today for the first time, and I can see why people want them. It makes a big difference since it takes all the pressure off your ear. But I found one on Thingiverse that seemed to be pretty popular, and it seems to work. It only takes 10 minutes. Is it 15 minutes? About 10 to 15 minutes per strap. Okay, let's do series. Ooh, this is a basic program? Enter the number of series resistances. Well, we'll go with 3. enter question mark for unknown resistance value. Okay, so we can, okay, so we'll let's put 100 ohms, 100 ohms, and I don't know ohms, with a total resistance of 121,000 ohms. Power, current, etc. What does that mean? I don't understand what this is. R in ohms, E in volts, I in amps, P in watts, and a resistor desired. R3. Inner supply voltage. I'm not quite sure what we just did. So let's do this. Nope, that's not what I wanted to do. So inner resistor desired, R3 for 12 volts, but we told it, I gave it a question mark for R3. So how does it know? Oh, because we told it the total resistance. Okay. Let's do this over. Let's do this one over. You guys can see that, right? Yeah. All right, so number of series resistances, let's just do 2. And then let's do a simple voltage divider. So, or is it, I guess it won't be able to show us this. Yeah, okay, I got it. Total resistance, 32, wait, no. Power, current, yes. Inner resistor desired, R2, for 10 volts. So, repeat, no, yes. I think I hit something. All I wanted was 2 resistors in parallel, 1,000, 2,000, nope, 1,000. Why does it, oh, okay. I want to start over. Okay, that's really starting over. Resistance. And we'll try to run it again. Isn't resistance futile? Where have you heard that? The only place you would have ever heard it was Star Trek The Next Generation, because Voyager was terrible, so there's no reason to talk about that. And none of the new Star Treks are any good, so no reason to talk about those either. Okay. I still don't... I think when we told it to repeat the calculation, it was keeping the total resistance from the previous ones, which I don't think it was supposed to. So there might be like a 40-year-old bug that we're dealing with here. Or I guess this would be like 30 years. I want R2 at 10 volts. Okay, now I understand what it's doing, because our total resistance is 2,000 ohms, 1,000 ohm each, 10 volts. So we get 5 volts across R2. We got our voltage divider. Come for the electronics, stay for the Star Trek hot takes. Not that I have an opinion on the new shows, but okay. Okay, let's see what else we got. So I wonder if this was just like somebody's like was this just somebody's their old disk and it just had a bunch of basic programs on it? I wonder if this is one that I downloaded from archive.org. So let's try Ohm's law next. Run that. Paul, yeah, shit. We should look him up at some point and see if we can find out who that is. So we got an Ohm's law triangle. Yeah. Enter the known values for E for unknown. So if we don't know what the applied voltage is, but I have 100 milliamps going through a 10 ohm resistor. I don't know what the power is. Oh, that's pretty smart. Yeah, because it wouldn't need it. So yeah, so I don't know why it came out as 0.11. I only want it 0.1. But just take 10 times 0.1, you get 1 volt. Power would have been 0.1 times 0.1. No. I squared R, right? Yeah, so 0.1 times R. So move the decimal over once and then move it back. Okay, cool. That's kind of handy, actually. I mean, it only takes 4 or 5 minutes for it to boot up and get going. That's way better than using Google. All right, what is satellites? And then TV convert. Okay, this actually has a lot of interesting things. Holy crap. Okay. I wonder if any of these are still in the air. And what could we possibly... Okay. I don't have any clue what to put in for longitude and latitudes. Okay. Okay. I want to see what TV convert. Okay, I'm getting off topic here. All right, that's kind of cool. I want to move on to the next program, but I do at some point want to see if we can find out if this person is still around. It'd be cool to know what they had. Is that to tell you where to point your satellite dish? That makes the most sense to me. Where is A2? I'm gonna load this one next. I haven't watched Cloak and Dagger yet, but War Games is one of the movies I really like to go back and rewatch. Probably, I won't say once a year, but right about once a year, I try to watch that one. My favorite thing about War Games is after he establishes that he has a box for his home computer that can do text to speech conversion, everywhere else he goes, the voice follows. And so even though he's away from home, they kind of skip over the fact that not every single device he uses has that text to speech converter. And it was something he had at home. And because I think at one point doesn't even call him or something. But I just remember he was like in Kittrick's, was it Kittrick? He was in the guy's office and the computer was talking to him. And I'm like, well, wait a minute. He doesn't have the voice box. So how's it talking? Okay. So this one is the one that was recommended to me by, oh, no, I forgot how to say his name. Something Matrix. So if you're watching, sorry, I totally forgot. You told me how to say your name and now I forgot. So I think what it's got going on is in the middle of the screen is a breadboard. And then these down here are switches. So there's 8 switches and, oh, nope, that's not what I want to do. When I do test circuit, I can press 1, 2, 3, 4, 5, 6, 7, 8 to turn them on and off. So we got that. What do we got? 4 and 6. And then over here, there are, I guess, these are push buttons, which I think we have to look in the directions. I think it's like Y and T or T and Y. Might control these. And then there's a clock signal, which I don't know what the speed of the clock is. Up here are LEDs. And then these are some 7-segment displays. So what we can do is let's load an example program. Oh, nope. Oh. Of course, that's not found. We need to list the circuits on the disk first. So let's load 7 segments. So 7 segments. Cool. And now we can do test circuit. And if I hit 1, it turns on the top segment. And then 1, 3. Okay, 3, 2. So 1, 2, and 3 make it a 7. Okay, turn that off. And then I don't see any valid reason why we should try to decode what all the segments are. Okay, but the idea is we can at least see that we can use switches, got the 7-segment display, got some LEDs. You can see what's going on with it. Now let's do a list of circuits and look at the up-down counter. So up, down, dash, count. Load from disk, up. See, this program is user-friendly because it keeps the disk listing while you go to, except the delete key doesn't work. So take that back. So up, slash, down, dash, count. Oh, look at all this stuff, huh? So it's got a 74,193. So excuse me for a second. I want to look up what is a 74,193. So it's a 4-bit counter with dual clock. All right. It has a carry and a borrow. Okay. And it's got 2 counters. I can't tell, but I think we're only connected to 1. See, this is where I get confused on the program. Thanks for the follow, by the way. I missed your username. There's sort of like this stuff going on here. And I don't know, does this mean that all these columns on the breadboard are connected or not? I'm not sure. I think it's only that this pin is connected to this pin, and then this pin is connected up to here. So then it looks like we go from the clock to here, and then from here over to something. This is where I wish I kept the pin out up. And then of course well, see, this is where now I'm confused because I see 1, 2, 3, 4. I see a bunch of connections up here, which are going into the decoder for the 7-segment. And then I guess this creates a bus. Don't know. Okay. Let's do test circuit. And I think if we do nothing, or there's switches, so I don't know if we're supposed to press something because it's got a clock. What if we do 1? What happens? Okay. Okay, so maybe it's just decoding. Or is this that we're selecting, oh, I think, is it that we're setting what the load, are we preloading the counter with something? 2, 3. Okay, why is 3 turn on 4? 4 turns on 8. Now I have no idea what it's doing. All right. I'm gonna hit the question. Okay, so move the probe. When the pinhole is positive, it turns orange. It turns blue when it is not on. I can use IJKM to move around. Okay. Turn on the switches using the numbers. That one I know. T and Y are pulses to the push buttons. The left and right side, okay. C to change the clock speed. Okay. So when we hit C, I don't know what that does. One, two, oh. Okay, I think Tisboyo got, I think, okay. Okay. Yeah, so the first 4 switches are just binary values. So if we wanted 3, it'd be 1 and 2, and then if we wanted 5, it would be 1, 2, and 1 and 3, and then 7 would be 1, 2, and 3. Okay, so I think, okay, that makes sense. And I think this is preloading the counter. So then what does 5 do? I don't know what 5 does. 6? I wonder, does 6 just clear it? 7? 7, I'm not sure what that does. And 8. Okay. I don't know how to make it start counting. Okay. All right. So I'm still not sure what it does, but that's okay. Let's do this. Let's clear the board and start with something brand new. So let's do design circuit. And let's see, 7400, that is a... How do we get other parts, I wonder? Okay, so that's how you draw a thing. That's not what, I didn't want to do that. Design a circuit. Does this have, oh wow. Oh wow. Okay, use the cursors to move around. Use the wire. Okay, I got that. Spacebar to start and stop a wire. A and B, advanced chips. Okay. And then we'll come back to this. Yeah, this is like using fritzing or something. Move a chip over the notch. Okay, I got it. So if I do B, okay, let's not let me change the chip, but let's go to the notch. Okay, that's cool. Now if I could only just remember what all the 7400 series were. So was it 7400 is NAND, is NAND, right? So let's take that and can somebody look up the pinout of the chip? I want to know what is which one are the 2 inputs and which one is the output. Yeah, no kidding. Where's the Atmel chip? Is there? I'm gonna cycle through these. I want to see, is there a 555? I highly doubt it, but that'd be awesome if there was. Oh, there's no resistors though, so it's got to be only digital chips. Bummer. Okay, let's see, 1 and 2 and okay, 1 and 2 and 3. So let's do a wire from here to here, and then do a wire from here to here, and then we'll tie the output to an LED. Oh man, that's not where I want it to go, but I don't want to figure out how to kill it. Now, is it, what I did notice in others, and I think we're going to do it, so what's the, is it 14 is So this should be negative, because I think the bottom is the negative rail and the top is the positive rail. Okay. So now let's test that. And so 1 and 2 is AND. So what's the table for an AND? Is it just 0, 0, 0, 1? Yeah, okay. That's at least what the circuit's doing. So that's pretty cool. Okay. I mean, you know, the funny thing is, I know there's like stuff like DigiSim or DigSim or something. I think it's DigSim, D-I-G-S-I-M. It's getting harder and harder to find 7400 series chips in DIP format. And so the funny thing to me is this may actually be a pretty good way to play around with them, just because where else are you going to find them? And of all the programs we looked at, to me, this is the most, this is the closest to like a real circuit, right? Is like, it looks like a breadboard. It's sort of acting like one. How do we delete lines? Because I want to try deleting the plus, like the VCC on pin 14. Now we have to go into design circuit. Design circuit. And then question mark here. So X erases it. So let's try that. So if we erase that line, and then we go into test circuit, and oh, 1, 2, 1. Yeah, so it doesn't work. That's so cool. Oh, that's cool times. I like that. I like that very much so. Okay. I wonder, one thing I want to do is I want a, let me do design. And I know this is going to be a little bit tedious, but oh, that's not entirely what I wanted to do. Sublime text. I have no idea what I just typed in. What I want to do is capture real quick all of the chips that this has, because I'm not sure if I've seen that list anywhere else. And so let's go 7400, 7402, B. Oh, I have to be on the chip to do it. B is, nope. Well, that's fine. All right, I'm just gonna do 193, 170, 154, 151, 150, 95, 90, 86, 83, 76, 75, 94, 54, 50. I do not recognize most of these. Sorry guys, I know this is not super exciting to watch me just transcribe this, but okay. And then I'll just save that later. Cool. Hey Thomas, how you doing? Okay, and then let's just do one more exercise and add a 7404, which is an inverter. And we'll just put it like here. And now we will connect its VCC, which I think is interesting. I wonder why it requires the chips to have the VCCs connected, because it's not like you're going to build a voltage divider or something and you're not going to power the chip from another digital logic chip. So it just seems like it should have worked without having to do that. Unless maybe the idea was you could put multiple chips on the board and then disable it by disconnecting the power. So now what we want to do, okay, what I want this to go is from here to here. Nope, that's not what I wanted. I think the 7404, it's channel. Pin 1 is input, pin 2 is output, but I'm not positive. No pun intended. So we'll take this. Yeah, that's starting to look like a breadboard I would make. Just wires snaked all over the place. I like it. All right, test that. Yeah, so now it's the opposite. Now it acts like a AND gate because both of the lights have to, or both of the pins have to be turned on. Oh, I know what we can do. I know what we can do. We'll hook up I wonder, can I do this, or is it going to connect those together? I guess we'll see. Let's test that. Nice. There we go. That's what I was going for. Yeah, thanks. I thought it was 1, 2, 3, 4, 5, 6, and so on. So now pin 3 is showing the output of the NAND gate, which is a negative AND, meaning that it will only turn on, it will only turn off when both inputs are the same. And then we run that also into an inverter, and that inverter just swaps it so that now pin or LED 7 looks more like, or LED 7 looks like an AND gate. LED 3 is an AND gate. Cool. All right, that was fun. So yeah, so I think my recap would be the stuff from the microcomputer simulation stuff, the microcap stuff, looks like the most professional possible tools, but they're not working very well because of my setup. And then that circuit plotter is really the one I want to figure out next. I want to see if we can find out what kind of input device it requires, because I'd love to be able to use that to draw a schematic. I don't know what we're going to do with it if we draw a schematic, but I think that would be cool. And then this breadboard program. So this is the Apple II digital circuit. Okay, I'll tell you what, I'll show you guys where this is at on archive.org. In the event that you want to play with it on your own, let's close this. And then if we go to archive.org, so I ended up doing, so this one somebody had sent to me, but I ended up doing a search for circuit. So I went to the Apple Computer Software Library on archive.org, search for circuit, and then I found, so this is one of the ones that we loaded that didn't really do much. Electronics disk 273B. This is actually, this is the one that had all the basic programs on it that we were going through a couple of minutes ago, or right before this one. Where is, I think, start, no. Where did it, I was looking for the one that had the batteries in it because I'm pretty sure I downloaded it from here. Oh, and I don't see it. Let's do simulator. Oh, this is gonna find a whole bunch of other stuff, isn't it? Oh, wow. So flight sim. Yeah, okay. I want to be careful there because that could take us down a whole nother path. So this one is called like the digital circuitry simulator. Oh, maybe I'll search for circuitry. I don't know what I just typed. Circuitry. Oh, look at that. Another program we missed. Okay. What is this? Digital. Okay. I think I know what's going on. Nope. Yeah, okay. Well, I tell you what, if you want the link for this one, come hang out in the Discord. I think actually on our Discord server in the retro computing channel, I think there might already be a link to this, and if not, I'll throw one in because I've got it bookmarked on my other computer, so I can just send you directly to it. So the cool thing about that is you don't need to have an Apple II. You can just use the archive.org simulator. So did I see Space Vikings? Yeah, I think I saw Space Vikings. Or do I even want to type in space? I can't even imagine all the stuff that's going to be on here. Space Vikings. Check that out. Emulation. Actually, I don't have a problem with emulation. Is it doing anything? Ah, oh well. Okay, cool. All right, I'm gonna start wrapping up here. I think this was pretty fun. The primary thing I had wanted to do was try to find out what kind of simulation type software was available. I think like I said, that microcap stuff we found was the most professional thing. This program, the digital simulator, or the digital circuitry simulator, I think is actually pretty cool. I think it'd be really fun to play with, especially if you had an Apple II, so it'd be kind of cool. If you guys come across vintage computer software that is intended for electronics, then please send it my way. I did a quick search for Commodore 64 stuff. I didn't find much. I did find a couple things on the Sinclair. So I think it was for the Spectrum, but I'm not sure I'm not sure which specific Sinclair it was designed for, but there might be some stuff there. I also think the BBC Micro might have some education/scientific applications, but I just thought when I saw this program, I thought it'd be interesting to see 30 years ago, if somebody used a computer to do some kind of design work, what would they have used it for? I think today it would be mind-boggling to think of designing a circuit without the use of something like KiCad. But 30 years ago, that kind of software really didn't exist. And we can see the stuff that did exist was not what you would call user-friendly. Even for the time, it wasn't user-friendly. Amiga, oh yeah, that's actually, there's got to be stuff on the Amiga. But yeah, so if you guys find stuff, let me know. The best way to let me know is either tag me on social media or join the AddOhms Discord, which you can get to by going to addohms.com/discord. So, in fact, if you guys want to keep the conversation going, then I would say head over there now, because I'm going to, after I sign off, I will be in there. For those of you watching on YouTube, if you would like to continue seeing live streams, I would highly recommend you check me out on Twitch. So if you go to twitch.tv/baldengineer, then you can follow me on Twitch. I'll still be doing YouTube stuff, but I'm going to start moving my live streams towards Twitch, and so just a heads up, so you might want to join over there. For now, I'm going to go. I want to thank everybody for stopping by. I hope you have a good Friday or Saturday morning, depending on where you are in the world. I did want to mention that I really appreciate you guys coming to the live streams. So this is my second week of doing multiple streams during multiple streams. You know, in the past, I would do them once a month at most. And so I've had a lot of fun so far talking to you guys while working on stuff that I would have worked on anyway. I hope you enjoy coming by and participating. And feel free to keep coming back. I'll have a new schedule posted on Sunday for the next week, and you can either see that on Twitch or in the AddOhms Discord. So one more time, thank you to everybody, and please stay safe.